The engine inside the Bugatti Chiron isn't just powerful, it's one of the most extreme feats of engineering ever put into a production car. Every component is designed to push the boundaries of speed, heat, and mechanical precision beyond what most vehicles could ever handle. But as incredible as these numbers are, the deeper you look, the more unbelievable the story becomes. Because the most shocking fact is still ahead. Number 5. It has an insane cooling system. The Chiron's engine produces such an immense amount of heat that a standard cooling setup simply wouldn't survive. To handle this, the car is equipped with an advanced thermal management system that includes 10 radiators strategically placed throughout the vehicle. These radiators cool everything from the engine itself to the transmission, turbochargers, differential, and even the air conditioning system. Massive air intakes feed cool air into the system, while carefully designed airflow channels direct heat out of the rear of the car. At high speeds, airflow becomes a critical part of keeping the engine alive, acting almost like a natural cooling force. Without this constant stream of air, temperatures would spike to destructive levels in seconds. The system also uses high-capacity pumps to circulate coolant rapidly, ensuring heat is constantly pulled away from critical components. This isn't just cooling, it's a full-scale thermal control network built to sustain extreme performance. Even the smallest details in the cooling system are engineered for maximum efficiency. The radiators themselves are larger and more complex than those found in most race cars, with intricate fin designs to maximize surface area. The cooling system can move dozens of gallons of fluid per minute, which helps regulate temperatures even when the engine is under full load. At speeds approaching 250 miles per hour, the airflow through the car becomes so intense that it dramatically improves cooling performance. Engineers had to carefully balance aerodynamics with cooling needs, ensuring the car remains stable while still allowing enough air to pass through. The rear design of the Chiron isn't just for looks, it's specifically shaped to extract hot air as efficiently as possible. This constant battle against heat is one of the biggest challenges in hypercar engineering. Without this system, the engine would overheat long before reaching its full potential. In many ways, the cooling system is just as impressive as the engine itself. Number 4. It consumes fuel at a shocking rate. When the Chiron is pushed to its limits, fuel consumption becomes almost unbelievable. At top speed, the engine can drain its 26-gallon fuel tank in under 10 minutes, which highlights just how much energy it demands. This level of consumption is the direct result of producing massive horsepower and maintaining extreme speeds. The engine requires an enormous amount of fuel to sustain combustion across all 16 cylinders, especially when all 4 turbochargers are active. At lower speeds, the car is relatively more manageable. But once pushed hard, fuel usage skyrockets. The fuel system itself is designed to deliver high volumes quickly, ensuring the engine never starves under load. Specialized injectors spray fuel with precision timing to maintain optimal performance. Every drop of fuel is used to generate as much power as possible, leaving little room for efficiency. The fuel delivery system is just as advanced as the engine it supports. High-pressure pumps ensure a consistent flow of fuel, even under extreme acceleration and high G-forces. The tank itself is built to withstand intense conditions, including rapid fuel movement at high speeds. Engineers had to account for fuel sloshing and pressure changes to maintain steady delivery. Even the lines and fittings are reinforced to handle the stress of such high demand. Driving the Chiron aggressively means frequent stops at the pump, as the engine burns through fuel at a staggering rate. This is not a car designed for efficiency. It's built for maximum performance regardless of cost. The sheer amount of fuel consumed is a reminder of the raw power being unleashed. It's one of the clearest examples of how extreme engineering comes with extreme trade-offs. Number 3. The turbo system works in stages. The Chiron's engine uses a highly sophisticated quad turbocharging system that operates in stages rather than all at once. At lower engine speeds, only 2 of the turbochargers are active, which helps reduce lag and improve throttle response. This allows the car to feel surprisingly smooth and manageable, despite its immense power. As the engine speed increases, the second pair of turbochargers gradually comes online, dramatically boosting performance. This staged approach ensures that power delivery is both controlled and explosive when needed. Without this system, the engine would either suffer from excessive turbo lag or become too difficult to control. The transition between turbo stages is carefully calibrated to be seamless, so drivers don't feel abrupt changes in power. This balance between responsiveness and performance is key to making the Chiron usable on real roads. It's a perfect example of how advanced engineering can tame extreme power. Each turbocharger is precisely engineered to handle massive volumes of air under intense pressure. The system includes complex piping and valves that regulate airflow between the turbos. As the second set of turbos engages, the engine experiences a surge in power that pushes it into hypercar territory. Engineers spent years refining this system to ensure reliability under extreme conditions. Heat management is also critical, as turbochargers generate significant temperatures during operation. The stage design helps reduce stress on the components by distributing the workload more evenly. This not only improves performance, but also extends the lifespan of the engine. The result is a system that delivers both instant response and overwhelming power when demanded. It's one of the most advanced turbocharging setups ever used in a production vehicle. Number 2, it produces up to 1,600 horsepower. The engine in the Chiron is capable of producing an astonishing 1,600 horsepower in its most powerful configurations. This level of output places it among the most powerful production cars ever built. With that much power on tap, the car can accelerate from 0 to 60 miles per hour in under 2.5 seconds. It continues pulling hard well past 200 miles per hour, reaching speeds that few vehicles in history have achieved. The engine delivers this power smoothly thanks to its advanced design and turbocharging system. Every component, from the pistons to the crankshaft, is built to withstand extreme forces. The drivetrain is also engineered to handle the immense torque generated by the engine. This level of performance requires precision engineering at every level. Generating 1,600 horsepower isn't just about adding more fuel or air. It requires a complete system designed for extreme output. The engine block is constructed from high-strength materials to handle the pressure and heat. Internal components are reinforced to prevent failure under stress. The transmission is specially designed to transfer power efficiently without breaking down. Even the tires must be engineered to handle the incredible forces generated during acceleration. The car's electronics constantly monitor performance to ensure everything operates within safe limits. This level of power transforms the driving experience into something almost otherworldly. It's not just fast, it's an entirely different level of automotive performance. Few machines on Earth can match what this engine delivers. Number 1, it's an 8.0-liter quad-turbo W16 monster. At the heart of the Chiron lies an engineering marvel, an 8.0-liter W16 engine that is unlike anything else in production cars. This configuration essentially combines two narrow-angle V8 engines into a single compact unit. The result is a 16-cylinder powerhouse capable of producing enormous amounts of power. The engine's unique layout allows for a shorter overall length compared to a traditional V16. This helps with packaging and weight distribution inside the car. The addition of 4 turbochargers further enhances its performance capabilities. Each cylinder plays a role in delivering smooth and continuous power. The engine operates with incredible precision, balancing power and stability. It's a design that pushes the limits of what internal combustion engines can achieve. Building a W16 engine is an incredibly complex task that requires advanced engineering and manufacturing techniques. Every component must be perfectly aligned to ensure smooth operation. The crankshaft alone is a masterpiece, designed to handle the forces generated by 16 cylinders firing in rapid succession. Cooling, lubrication, and airflow systems are all carefully integrated to support the engine's performance. The compact design also helps reduce vibrations, improving overall drivability. Despite its size and power, the engine operates with remarkable refinement. This combination of brute force and precision engineering is what sets it apart. It's not just powerful, it's one of the most sophisticated engines ever created. And in many ways, it represents the peak of internal combustion technology. Thank you for watching. If you enjoyed it, please like and subscribe. Until next time.